Electrolysis is a way that we can reverse the electrochemical reaction. So previously we looked at fuel cells where we took hydrogen and oxygen and combined them to make water. Well, if we hook up a battery and have electrodes in our water, we can actually produce hydrogen and oxygen from the water. And this is the reverse of the reaction that we just saw in the fuel cell. And this happens in what we call an electrolytic cell. And electrolytic cells, they can actually produce pure elements by undergoing electrolysis. Now, a voltaic cell is what we've been looking at, or a galvanic cell is what we've been looking at up until this point, where we hook up our electrodes and the electricity or the electrons flow spontaneously from one of the electrodes to the other. We can measure that voltage. The electrolytic cell, we are hooking a battery up instead of a voltmeter. And you'll notice that our electrons are now flowing in a different direction. So we're flowing from the copper to the zinc in this case, where before we were going from the zinc to the copper. Our electrodes have reversed. So what was the cathode before in our voltaic cell, in our electrolytic cell has now become the anode. And this is because the electrons are flowing away from it. We are pushing the electrons the other direction. This is the process that is used for electroplating. So if we want to coat a thin layer of metal onto a, say, jewelry or cylinders in an engine, we can use electrolytic cells in order to do that thin coating of metal. Elements can also be purified using electrolysis. So this is an example where we are taking molten salt, molten sodium chloride, and it does have to be in the liquid state so that the electrons and the ions can flow to the electrodes. Normally the electrodes used in this particular example are graphite, and the cations are being reduced, the anions are being oxidized, and by setting this electrolytic cell up of molten sodium chloride, we can actually produce chlorine gas, and we can purify pure sodium metal that gets actually plated right onto the electrode on the cathode side of our cell. We don't have to only do electrolysis of pure substances. We could have mixtures. And if we do have a mixture, what is going to happen is the easiest to reduce is going to be reduced at the cathode. So the least negative or most positive standard cell potential for the reduction. That is going to be the first one to be reduced. Now, an easier way to think about it, instead of saying least negative or most positive, it's going to be the potential that's closest to 0 from the list. Okay, so if we have 2 of them, the one that's closer to 0 is going to be the one reduced. If we have more than one anion, okay, the one that's easiest to oxidize will be the first one to be oxidized at the anode. And again, it's going to be the one that's closest to 0 from the potentials that you're given. We have a mixture of molten aluminum bromide and magnesium bromide, and we want to figure out what the half reactions or which reactions are going to be occurring at the anode and the cathode during our electrolysis. And so we've got a couple reactions that are going on. So we've got them written for our cations. We've got aluminum and magnesium. The other reaction that is going on is bromine. Okay, and so our bromine is going to be at the anode. The anions are going to be at the anode with the oxidation. We have to figure out which cation is going to be at the cathode. So we look at the cell potentials that are given to us. We're looking for the one that's closest to 0. And in this case, our closest to 0 is going to be the aluminum. And so the aluminum is going to be our cathode reaction. So the cation is being reduced at the cathode. So our two reactions would be bromine and aluminum. So here's one for you to practice. Now we have the same cation, but we have different anions. Predict which reactions are going to be at the anode and the cathode. So let's start with the magnesium because that one is in common for both. So we know that reaction, the cation, is going to be occurring. And so because it's the cation that is being reduced, this is going to be our cathode. Reaction. Now we have to figure out which is oxidized at the anode. So we look at our cell potentials. We can see that the bromine is closer to 0. And so the bromine will be the reaction at the anode. Because it's closer to 0, it's going to be easier to oxidize. So what if we're not molten? What if we don't have molten solutions, but in fact we have aqueous solutions? Well, when we add water, it also allows us another potential oxidation or reduction that can occur. And so the half reactions that are closest to 0 are going to be the ones that occur in our electrolysis cell. So if we look at our oxidations, we've got two possibilities. We've got iodide to iodine, but we also have water that can produce oxygen. So we do need to look at, just like we did with the mixtures, the one that's closest to 0 is going to be the one that occurs in the cell. So in this case, with iodine, the iodide to iodine is going to be the oxidation half reaction. Okay, so same idea. Now we're looking at the reactions that could potentially happen at the cathode. So we're looking at sodium and we're looking at water producing hydrogen. And again, we look at our cell voltages, and in this case, our hydrogen is closer to 0, and so that is the reduction that occurs in this electrolysis cell. So we can produce iodine, but the sodium is not going to be reduced. Our water is going to be reduced instead. And so our overall reaction is going to be the iodide producing iodine and our water producing hydrogen and hydroxide for the electrolysis in our cell. So here's an example. Predict the half reactions occurring at the anode and the cathode for lithium iodide. So we want to look at our oxidation and our reduction. And so these are labeled in that way. We can tell because the electrons are on opposite sides of our chemical reaction. And so the first two are going to be the ones we compare for oxidation, because oxidation is loss of electrons. And the second two are going to be the ones we compare for reduction, because reduction is gain of electrons, and we can tell by the side that the electrons are on. So looking at our first two reactions for oxidation, we can see that the iodine to iodide is the one that's closest to 0. And so that is going to be the reaction that happens at the anode. We look at our two reduction reactions and we look for the one that's closest to 0. And so our water is going to be reduced to hydrogen, and this is going to be the reaction that happens at the cathode. So by looking for those voltages that are closest to 0, these are the reactions that are going to occur. So here's a practice for you. See if you can determine which of the reactions are going to occur and where they are occurring at. So again, we are going to look at our oxidation reactions, and we know these are oxidation because the electrons are on the product side. We're going to look at the reduction reactions, and the electrons are on the reactant side. And we're going to look at which one is closest to 0. So for our oxidation, in this case, the water is going to be oxidized to oxygen and H+, because it's closest to 0. And for our reduction, the reduction is also going to be water reduced to hydrogen and hydroxide, because it is closest to 0. And so our oxidation happens at the anode. Remember, anox and red cat. So our reduction is at the cathode. And so we've determined in this mixture of water and sodium bromide, it is going to be our water that ends up oxidized and reduced in this example.